Alright, this week we're going to go over the practice test for interpreting line graphs and other graphs. Problem number 1 says what point or points on the graph let you know that Marie stopped before going to work. Make sure you can see it from back there. So here's what our graph looks like. And the first thing you want to check out is how it's labeled. And the y-axis says this distance from home in miles. So the higher up you go, the further you are from the house in miles. Going across the x-axis, of course, is time. And so number 1 says what point or points on the graph let you know that Marie stopped before going to work. Now this is tricky because you got two things. People are going to gravitate towards C and towards the DE part right here. This one on the graph, it's actually perfectly flat. It's perfectly straight going across there. And so what we have is point C says that Marie came back home. It doesn't indicate that she stopped. This flat line right here between DE, it says that's approximately probably 7 miles away. She was 7 miles away from home for 5 straight minutes. She may have just been waiting through a long red light, or she may have stopped somewhere really quickly, but this horizontal line indicates that she was not traveling for 5 minutes. So when it says what point or points, it would be points D, E. Those would be the 2 points, as indicated right here. All right, I'm going to scroll up to the next problem. We need to see all of the graphs. So problem number 2, select the graph that matches the following situation. Mr. Math starts off, actually says starts of, but it should say starts off from his house and jogs for 30 minutes before running 6 minutes, after which he takes a 20-minute break. All right, so let's break this down into segments. He starts from his house and jogs for 30 minutes. So we had from his house and we had jogs 30 minutes, and then we have running for 6 minutes, and then after that we have a 20-minute break. So let's take a look. The graphs are labeled as, on the y-axis, distance from his house. Well, it said he started at his house, so we're looking for a graph that starts at 0. Looks like all of the graphs start at 0 distance. All right, so they all fit that, so they're all starting at his house. And so now we're looking for one that jogs for 30 minutes. So jogging is not going to be as fast as his running, so we're looking for one with a slant that maybe is not quite so steep. Jogging, maybe the slant, the rate of change is fairly flat or shallow, and running is going to be a steeper one. So let's take a look. All right, it looks like graph A and B start off fairly similar. Probably still similar even on C. Looks like there's a long break on choice D. So D indicates that there's a 30-minute period of doing nothing. So D is probably not going to be it. So the jog is a 30-minute segment. So let's look for one that is 30 minutes. So segment 1 here is between 12 and 18. So probably about 15 minutes. That is not going to be it. We're looking for a 30-minute segment 1. So A is probably now eliminated. Choice B, same thing. Looks like about a 15-minute segment. It's now eliminated. Choice C, from 0 minutes to exactly 30 minutes. It has a 30-minute segment 1. This may be the jog right here. So let's take a look. So we are looking for a 6-minute run after that. Pretty steep. Let's see, it goes from 30 minutes to exactly 36 minutes. So this would be a 6-minute run. And then it said he rests for 20 minutes. He has a 20-minute break. So from 36 to about 56, there is no movement. He's not getting closer or further away. So this would be a break right here, and the time does fit. So choice C definitely matches that scenario. Problem number 3, what is the initial value? Based on that graph, the initial value right here, often called the y-intercept, is about 25, and it says that that is the total charge in dollars. So the initial value would be $25. Number 4, which function has the greater rate of change? Well, the rate of change is indicated right here. It's the slope. Rate of change is always slope. Rate of change when it's asking which one is the greater, it's just the greater change. Doesn't matter if it's positive or negative, it's which one is further from 0. So when we compare -5 to 3, the -5 is a bigger change. It's a 5-unit change versus a 3-unit change. So -5 is a greater change than 3. Problem number 5. How long does it take the car to reach point B? All right, so how long does it take the car to reach point B? Right here on the graph. So we just need to find the time in minutes, and that looks like 80 minutes. So we could simply write 80 minutes, or if you wanted, you could write 1 hour and 20 minutes. Either way would be fine. Number 6, what is happening between points E and F? All right, so E and F. So we got this flat line right here on E and F. And we've got distance on the y value. So it's indicating that's 150, I believe this is in miles. So 150 miles at point E, 150 miles in between, and still we've only gone 150 miles at point F. So while time has elapsed, looks like maybe, let's see, 20, looks like maybe 40 minutes have elapsed. We haven't moved anywhere. We haven't gained any mileage. So what's happening there is we are sitting still, or choice B, the car is staying in the same place. Okay? You would pick speed if this axis was in speed, but this axis is in distance, indicating that we have not traveled anywhere. All right. Problem number 7. For which x values is the graph increasing? Well, we're looking for a positive slope. That's a 0 slope, negative slope, positive slope. And that's from here, which is at x3 to x6. So we're looking from x3 to x6. So that would be choice C. X equals 3 to x equals 6. All right. Number 8, write the equation for the linear function represented in the table. All right, fill in the missing y value for x minus 4. All right, so 0, 1, 2, 3, 4. We've got a constant rate of change here on the top. On the y values, 2, 0, -2, -4. So we can tell that the y value it does have a constant rate of change, and it's decreasing by 2 each time. So we know that that's going to be a -6. Write the equation. So the first thing we need to do is we need to find the slope. Finding the slope is going to be y2 minus y1 over x2 minus x1. We can pick any 2 points we want. I would pick the first 2 right here because they're all positive. This would be my x1 value and my x2 value, my y1 and my y2. So if I follow the formula, that would be, let's see, this would be a good spot to write it, I guess. 0 minus 2 over 1 minus 0. 0 minus 2 is -2. 1 minus 0 is 1. So we can simplify this into -2. That is my slope. All right, so far I know I have y equals -2x. So I've got the slope. I just need to find out what the plus b is. All right, so y equals -2x plus b. Let's solve for b and find out. Now, you may remember that there is a trick if you have an x equals 0 in the table. If you have an x equals 0 in the table, that means you're on the y-axis. Anytime x is a 0, you're already on the y-axis. So that would be a gift. You should know at this point that it's going to be 2. But let's find out just to make sure. Y is a 2 if I choose this point. So -2 times x, the x is a 0, plus b. So if we simplify this, this is 2 equals 0 plus b, which is just 2 equals b. So we find out that the intercept is plus 2. And we knew that because x was a 0, the y value was the intercept. All right, I'm going to erase that and scroll up. All right. How much does 1 gallon of gas cost? Well, 1 gallon. So we need the per one price. Now, that's indicated right here, but it's very difficult to tell what value that is. We know it's above 2, but it's below 3. but I feel like we're kind of guessing. So what we need to do is we need to use two good points. That first one is not a good point, but the second one right here is a good point, and that would be x value is 2, and the y value would be 5 or $5. All right, we need a second good point, which we could use 0, 0 right there. All right. So if we find the slope, this is going to be, x1 and y1, x2 and y2. So we have 5 minus 0 on top of 2 minus 0. 5 minus 0 is 5. 2 minus 0 is 2. So we have 5 over 2, or in this case, since we're talking about a dollar amount, this would be 2 goes into 5 2 whole times, and that would leave 1/2, which would be 0.5 or 0.50 in this case, since we're talking about money. So how much does 1 gallon of gas cost? $2.50. Another way to look at this is 2 gallons would cost $5. If 2 gallons cost $5, how much would 1 gallon cost? And you could actually do this as a proportion. You could do 2 gallons over $5. We want to know 1 gallon. We don't know the price. Gallons, price. 2 times x is 2x. 5 times 1 is 5. All right, we would divide by 2 to solve this, and x would equal 2.5. So 2 different ways to solve this, proportional or using slope. Is this a direct proportion? Yes, it is. It does start at the origin. It is a linear function, so yes. Number 12, Jared is building a tree house. He pays $75 for materials and pays his friend $10 per hour. All right, I'm going to go ahead and underline some stuff. $75 for materials and pays his friend $10 per hour to help him. If Jared spends a total of $150 on building his tree house, how many hours did his friend work on it? All right, so we know the total is $150. That's going to replace the y in your equation. The y is always how much did the whole thing cost? So $150. $10 per hour. Per is always an indication that you're talking about the slope. So 10x, and then $75 is the material price. So that's the starting point. The cheapest this could be was $75. That's where we started at. So what we want to do is solve for x, because x is the number of hours the friend worked. So step 1, we would subtract 75 from both sides. So we get 75 equals 10x. Divide both sides by 10, because we want to separate the 10 from the x. And we get 7.5 equals x. So the friend worked 7.5 hours. All right. What is the rate of change for the first segment of Malik's walk? Okay, the first segment, segment number 1. So let's take a look at what we have. The x value and the y value for this first point are 0, 0. And if we use the second point here, we would have 2, 6. So we could use those 2 points. We could also look to see if we have a good point at the 1 hour mark. We do have a good point at the 1 hour mark. If we look right here, we know that this would be 3 miles. So it's going to be 3 miles per 1 hour, or 3 miles per hour. However, if we didn't have that good point, or we didn't recognize it, we could just do the whole y2 minus y1 situation. So I'm going to label these x1, y1, x2, y2. So I have 6 minus 0 over 2 minus 0. 6 over 2 equals 3. So our slope is 3, and in this case it's 3 miles per 1 hour. Notice we had the same number with that good point right there, 3 miles per 1 hour. How long did Machism take a break? how long did he take a break? So the break is right here, and that is from hour number 2 to hour number 3. So he took a break for 1 hour. $15. Alright, not totally sure how to pronounce that name. I'm just going to go with Shaban. Is a speed walker. The graph below shows the distance she walked while training for a marathon. Okay? During which part of the training walk did Shabana walk at the fastest speed? Alright, so the fastest speed is going to be when you're covering the most distance in the shortest amount of time, or in this case, the steepest positive slope. And we can see the two slopes right here. This one is steeper. It goes more vertical than the second, or technically the third segment here. So when it says the fastest, that's going to be from hour 0 to hour 2, or the first segment. So let's take a look at what we have. During the first 2 hours, between hours 2 and 3, hours 3 and 5, or she walked at a constant rate of speed for the entire training. We know that she didn't do this. And we see that it's between the first 2 hours. So this is going to be A, her first 2 hours for the fastest speed. And she was actually walking at 6 miles per 1 hour. If we take a look at the second segment, she's actually taking a break. And in the third segment, let's see, she went 3 hours to 5. She went 2 hours, and her distance was 8 miles. 8 miles in 2 hours would be 4 miles per hour for the last segment. So she had 4 miles per hour here, and she had 6 miles per hour in the first segment. So definitely the first segment. $16. Going to match these scenarios to a graph. Amanda turns on the oven and sets it to 350 degrees. When it's done preheating, she bakes a tray of cookies. Then she turns the oven off. Okay, so we're looking for an increase, a constant rate of temperature when it's baking, and then a cool down period again. Now, looks like the only one that rises in temperature, has a constant rate, rises constant, and then cools back down is graph 3. Now, I ask many times, why does this graph not start at 0? It doesn't start at 0, nor does it end at 0. So an oven that's never been turned on in a length of time, it hasn't been on in quite a while, why would it not start at the bottom of the graph at 0? And the reason being is the room temperature is not 0. The room temperature in a house or business is probably near 70 degrees. So an oven that's sitting there that hasn't been used that day would be around the same room temperature. It would start at about 70. And it would never cool down below the room temperature. Okay? So 17, Mrs. Fox came home after being at school and her house was so cold. She turned the heater on and it started to warm up. After a few hours it reached 70 degrees and she kept it that way all night. So we're looking for a low temperature, a rise, and then a constant temperature. So low temperature, rise, and then a constant. Graph 1. 18, Coach Woods has a hot cup of coffee. He leaves it on his desk to cool, but forgets about it. When he returns, it's room temperature. So he leaves it and does not drink it. So it was hot, and then it cooled down, and then once it reached room temperature, it never got any colder. So hot, cools down, room temperature. Or hot, room temperature, heated back up. Now, does it say he heated it back up in our scenario? No, it does not. So graph 4 is going to be the best graph. All right. Number 19. Does this graph show continuous or discrete data? Remember, discrete means things happen at a certain interval and there is no in between. So it says the cost of gasoline. When you're pumping gas or when your parents are pumping gas, they don't have to get an exact gallon amount. They're able to stop pumping at any spot. And if they wanted to stop pumping at, say, just a half of a gallon, we could go ahead and determine how much a half gallon would cost. Now, the quick and easy method to know if this is discrete or continuous, that is, Are the dots connected by a line? If they are connected by a line, this indicates continuous data. All right. If they were dots on a graph like this, and they were not connected by a line, this is what discrete data would look like. It would not be connected, and it means you cannot have an in-between value. It's one or the other, but nothing in between. Number 20, let's scroll that up. Identify the graph below that best represents the relationship between the distance traveled by a motorcycle parked in a parking lot. The distance traveled by a motorcycle parked in a parking lot. Think about that. It's parked. All right. So how much distance will it travel if it's parked? It's a trick question. It won't travel any distance. So we're looking for the distance to remain exactly the same. The only one on here that has the distance the same is B. And what this indicates is the distance in miles may be from the person's house. So maybe he's 10 miles from his house, and his motorcycle stays 10 miles away from the house all day. Perfectly legitimate. Choice A says that the motorcycle is getting further and further away. That's not true. Choice C says the motorcycle is getting further away and the rate changes. At first it's a little bit slower, and then it gets to very fast. Like maybe it was in the city and then it got on the expressway. Choice B is the only one that indicates the motorcycle was in the same place all day. So choice B for that one. All right. The graph on the right shows the relationship between the number of hours William works at his job and the amount that he earns. According to the graph, how much money will William earn in 4 hours? Okay, so we go to the 4-hour mark, we go up until we hit the function line, we go across. We have to figure out, it's counting each one of these tick marks as 10, so that's 10, 20, $30. Okay, so he makes $30 in 4 hours, okay? And that is what it's asking, $30 in 4 hours. From that point, we can figure out what his hourly rate is. There's two ways. You can do 30 divided by 4, and you'll get the hourly rate. Or you can set it up as a proportion, 30 over 4. This is dollars over hours. We want to find out how much he makes in 1 hour. So we're going to put an X for the dollar amount. So 30 times 1 is 30, and that would equal 4X. So just like I said, you could do money divided by hours. We're about to do money divided by hours. And we find out that X equals 750, if I'm not mistaken. 750 plus 750 is $15. 15 times 2. All right, that's right, 750. So I have 7.5. So when we write that down as an hourly rate, that's going to be 7.50 because we're dealing with money. We're going to go to 2 places past the decimal point to the hundreds. Number 23, W to the third, inside parentheses, to the second. That is power to a power. You don't have like bases. You have power to a power. You multiply the powers. So that's W to the 6th power. Number 4, if we translate negative 3, 5 down 2 units and then reflect over the y-axis, what is the new ordered pair? So the first thing is to translate down 2 units. So that's going to be minus 2. I'm just going to rewrite this problem right here. It's going to be minus 2 units, but does that affect the x or the y? Okay, up and down is controlled by the x value. So we're going to take away 2 from, I'm sorry, I think I said that incorrectly. We're going to take away from the y value because the y value controls the up and down movement. So we have negative 3, 3, but we also have to reflect over the y-axis. And if you remember, when you reflect across the y stays the same and the x changes sign. So when we reflect across the y stays the same and the x changes sign. So our new point will be 3, 3. That'll be our new prime point. 25, if angle A is 122 degrees, I'll write that in, 122 degrees, what is the measure of angle B? Well, we can see we have a straight line here, so altogether, these two have to make 180 degrees. If together they make 180, and A is worth 122, we simply subtract. 180 minus 122 is 58 degrees. All right. All right, that is the end of the practice test.